Hello, my name is Samuel Hui, and today are we going over how to do problem 1 of exam 3. So, the problem gives us that a block of mass m is moving along a frictionless floor at an initial velocity v naught towards a ramp with a mass of 3m that's also frictionless. It then elastically collides with the ramp and goes up along the incline to maximum height. It then slides down and separates from the ramp. And our task here is to find what the maximum height is for part A. Let's define some things first before we can do anything. So let's say up is positive y and right is positive x. Let's also say that when the block goes towards the ramp is the initial condition, and the final condition is when it goes up the maximum height along the incline. Finally, let's say that the ground is the height of 0, and h is the height the block goes up, and we need to solve for that h. So final height will be h, and initial height we did ground, which is 0. Like with any system, we can say that the law of conservation of momentum holds true. The momentum of the ramp in an initial condition would be 0 because it's at rest. The momentum of the block would be mv naught, which is the initial velocity and its mass. In the final condition, the block is at rest relative to the ramp. However, the ramp is moving because the block elastically collide with it. So the final momentum ends up being the sum of masses times that final velocity, which I'll call Vf, that they're both moving at the same time. And we see that Vf is equal to V naught over 4 if we solve for it. Since it elastically collides, the work energy theorem holds true. Like what we saw with momentum, the ramp has no initial kinetic energy because it's at rest, but the block does, and it's equal to 1/2 m v naught squared. It has no potential energy because they're both on the ground, which has a height of 0. Now, normally for non-conservative work forces, we would be able to ignore that because normal force and gravitational force is perpendicular to the motion of the objects, and cosine 90 degrees is 0. However, we see that the normal force from the ramp acts on the mass, and they're both moving at a velocity which is this way, so they're not perpendicular. However, the ramp also has a non-conservative work force acting on it, and it's from the normal force acted upon by the block this way, and it's also moving at that velocity, so at the end they just cancel out. The final kinetic energy for both objects would just be 1/2 times the respective masses times the same velocity that they're both moving at the same time. And I'll just write it out right here. And the final kinetic energy, only the block would have final potential energy because it actually is at a height of h and not 0. So it would be its mass times gravitational constant times that height. We already found out what Vf was. It's V naught over 4. So we end up getting that mv naught squared over 32 plus 3mv naught squared over 32 plus mgh is the final total energy. And now we're free to solve for h. Canceling out all the m's and solving it for h gives us h equals 3 v naught squared over 8g. Now we need to solve for part b, which is what's the final velocity of the block once it separates from the incline. Well, now let's call what we called final in part A initial in part B, which means that our potential, which means that our total energy in part A finally will be initial here in part B, and our final momentum in part A will be initial momentum in part B. Let's call this, when it separates, final. Let me just copy down here for simplicity. Now, we just need to discuss. First, let's just evaluate this. This is just m v naught squared over 8 plus mg, our new height that we found. These gets out, free mv naught squared over 8 plus mv naught squared over 8 gives us v naught squared 4 over 8 v naught squared over g. 4 over 8 v naught squared, which is just 1/2 m v naught squared. In the final condition, the block is going to have a final kinetic energy 1/2 times its mass times the final velocity of the block squared. And likewise with the ramp, except free m instead, times vrf, final velocity of ramp. Cancel out the m's and the 1/2, and we get v naught squared is equal to vbf squared plus vrf squared. How do we go from here? There are two unknowns and we just want vbf. Let's go to the law of conservation of momentum. Initial momentum is final momentum from part A, which is just 4m times vf, which is v naught over 4. Final would be the momentum of these, which is the respective masses times the respective final velocities. Rho squared. And we end up getting vrf is equal to v naught minus vbf over 3. Now that we solved for that, we can plug vrf back in, and we get v naught squared is equal to vbf squared plus 3 times that entire thing. Now you would have to do a lot of expanding, canceling out common common factors, but I'll just spare you the stuff and give you what you should eventually find after doing all that I just said. 2vbf squared minus vo vbf minus v naught squared is equal to 0. Quadratic function. And distribute them and you find out there are two clear answers for what the final velocity of the block could be. Let's look up here, back to the diagram I just showed. It only makes sense that the block moves left after it goes down the incline, which means that our answer has to be negative according to the coordinate system. And we see here that there's one positive answer and one negative answer for our final velocity of the block. It has to be a negative answer based on what I just said. And then we find that out, and part C asks for the final velocity of the ramp, and we have an equation here. We can just plug that back in, and we see that the final velocity of the ramp and what our answer is to part C is just equal to this, which just ends up evaluating to 1/2 VO. That's our answer for C. Thank you.